Okay, hello everyone. I just wanted to go over a couple of homework problems to help you in regards to how you should think about doing proofs from these sections and just to give you more practice. So if you want to pause the video to write this problem down, you can, and then we'll go over the proof. Okay. All right, so this is from chapter 6, the ninth edition. You might have a different edition, so check. It might not be number 13, but you should have this problem in your book. And the first thing I'm going to do, this is an if-then proof, right? So we're going to suppose G and H belongs to G, which we know we're referring to a group here. And we want to show that phi of G composed with phi of H equals phi of GH. Okay, well, let phi of G of X equals GX G inverse, and phi sub H of X equals HX H inverse. Okay, so that's from the definition. We talked about that a while ago. So phi of G composed with phi of H of X, that is equal to phi of G of H. Well, let me do this step first. Phi H of X, right, which equals phi G of HX H inverse, and that equals GH X H inverse G inverse, right? And this equals GHX GH inverse. That's by the sock shoe property, which is equal to phi GH of X. And we are done. Pretty straightforward, just understanding the definition, not too bad. Okay, so here's our next problem. We're supposing that phi goes from Z50 to Z50 is an automorphism with phi of 7 equals 13. Determine a formula for phi of X, okay? And so you should have read in chapter 6 about how they gave you an example dealing with automorphisms and showing like Z10, and make sure you go over that that sort of problem, how they dissect and break it down, as well as the properties acting on isomorphisms with elements and with groups, right? And so because of that, we know that 1 is a generator in Z50, and in fact in Zn in general, right? 1 is a generator because it gives you the entire group back, right? And so because of properties, that tells us that phi of 1 is also a generator, okay? Okay, for Z50, okay? And in fact, phi of 1 belongs to U of 50, and that's because all the generators in Zn are relatively prime, right? And so that would be the set U of 50, right? And this is not, you don't necessarily need all this information to solve this problem, but I wanted to make sure you understand and just give you some information, so when you're studying, you'll know how to approach things involving automorphisms and phis and things of that nature, and how you want to think about it. And something else that we really don't need, but remember to figure out how many elements are in U50. That's the same as computing phi of 50. Now this is the Euler phi function, right? Whereas this is just this phi is just a general function. So maybe I should have used another. We usually use Greek letters now, but maybe I should use another one. Okay, but you really should know from the context of the problem which phi you're talking about, right? And so this is just a quick review here. So that's phi of 25 times phi of 2, right, by properties. And so that's phi of 5 squared times, well, that's just going to be 1, right? And that is 20. Again, you don't necessarily need to know this information to solve this problem. I just wanted to give you some additional information since we're talking about this. Now, to find a formula, you really need to find your phi of 1, okay? Because that's going to be the base of everything else because it's your generator, okay? It's and that's going to be the basis dealing with 1 because you can rewrite everything in terms of 1, right? And so in order to do that, so we need to find phi of 1 given that phi of 7 equals 13, okay? Well, phi of 7 is the same as phi, and I'm doing this just to make sure you guys understand what's going on. Because we are assuming this is an automorphism, we have the isomorphism, which means we have the homomorphism property of preserving. Okay, 1, 2, 3, 4, 5, 6, 7. Okay. And again, you don't need to go through all this, but because I don't think I've talked about this directly in class, it'll be nice to just make sure you understand this. So because we have the homomorphism property, this is phi of 1 plus phi of 1, right? All the way, how many times? 7. So I can rewrite this as 7 times phi of 1, okay? And we know that 7 times phi of 1 equals 13. So we need to find phi of 1. So thus, phi of 1 is going to be 7 inverse, all right, times 13. Okay. So again, we are trying to find phi of 1 to ultimately get our equation for phi of x, because that is just going to equal x times phi of 1. Okay. And I don't think I stated that because of what we just did in the homomorphism property that we have, because we're assuming we have this automorphism. All right. Well, so what is the inverse of 7 in mod 50? Okay, so the inverse of 7. So in other words, 7 times what will be congruent to 1 mod 50? And there are different ways, because this isn't a number theory class. There's a systematic way with the Euclidean algorithm to solve for this. But now we can use sort of a little trick of what we know about mods. And that trick is this. I can rewrite 1 in mod 50 as negative 49, right? Because all I did was take 1 and subtract it from 50 to get what it's equivalent to. Okay. So why did I do that? Because now I can rewrite negative 49 as 7 times negative 7. And by left cancellation, y is going to be equal, congruent to negative 7, which is, actually, it should be, we should look at this as an equation. Yeah, so this should be an equation. Okay, make sure I get that right. Okay, but we are in mod 50. And so y is equal to negative 7. So we did left cancellation here. So y is equal to negative 7, which is congruent to 43 mod 50. So that's the inverse. So now we can go back and look at our problem. Okay, so that tells us that phi of 1 equals 43 times 13. So I'm replacing 43 in for the inverse of 7, okay, in my 50. Well, this equals 559, which is congruent to 9 mod 50. And so for our final answer for this particular problem, given that phi of 7 is equal to 13, phi of x will be what? Well, it's x times phi of 1, and we just saw that phi of 1 is 9, so it's 9x, okay? And you can check to see that it satisfies our two conditions, that phi of 1, right? Phi of 1 is 9 times 1, which is 9, and phi of 7, which is 9 times 7, which is 63, is 13 in mod 9. And mod 50, I'm sorry. So this is correct. All right, so these are the two problems I want to go over. I'm going to stop this video and do another video going over some problems in chapter 7.